Look down right now. Seriously, check out exactly what you're wearing, because we've got to clear something up immediately. There is this massive, incredibly common misconception floating around the entire global fashion industry, retail stores, and honestly, your own closet. People constantly throw around the words jeans and denim as if they're the exact same thing, but welcome to this explainer where we're going to completely dismantle that assumption. Because as a textile technologist, I can tell you with absolute certainty, you've been misled. They are entirely different things.
Write this down, memorize it, put it on a t-shirt. This is the absolute golden rule of material science. Denim is the fabric, jeans are the garment. It's a fundamental structural difference. Denim is the raw, highly engineered material. Jeans? Well, jeans are just the constructed clothing piece that you're probably wearing right now, built out of that fabric. Today, we're stripping away all that clever retail marketing hype and diving straight into the hard, quantifiable engineering science to prove it.
Here is our laboratory testing sequence for today. 1. The Great Denim Misconception. 2. The Geometry of Weaving. 3. The Chemistry of Fading. 4. Timeline of Textile Innovation. 5. The Engineering Trade-offs. And finally, 6. Global Dominance and Applications. All right, let's jump in.
Phase 1. The Great Denim Misconception. Look, modern retail spaces mix these terms up casually all the time. But to truly understand what's happening on your body, we have to keep things strictly academic. Denim is definitively a rugged, highly durable, twill weave textile. It is literally the physical cloth. Jeans, on the flip side, historically and technically describe the actual garment, the pants themselves, which are constructed from specialized fabrics. Separating the textile giant from the final garment is the very first step to seeing your wardrobe in a completely new light.
Moving right along to Phase 2, the Geometry of Weaving.
If we zoom way in to a microscopic level, the foundation of all our woven materials really just comes down to the interaction between two sets of threads. You've got the warp, which refers to the longitudinal or vertical yarns, and you've got the weft, which are the transverse horizontal yarns. I absolutely love looking at this because the precise mathematical way these vertical and horizontal threads cross over and under each other, that's what builds the sheer structural integrity of the fabric.
And this is where the magic happens. Asymmetry. Denim is fundamentally a warp-faced fabric. During the mechanical weaving process, only the vertical warp yarns are dyed, traditionally using this deep electric indigo, while the horizontal weft yarns are left raw or stark white. It's totally asymmetric. Contrast that with true historical jeans fabric. In a classic jeans twill, both the warp and the weft yarns are dyed the exact same color. That gives you a solid dyed uniformity that looks identical on the front and the back. There's no classic white reverse side in a true jeans fabric.
So how does this actually play out on an industrial loom? Let's break down the mechanical process for denim's heavy 3-4-1 twill weave. Step 1, that thick, indigo-dyed warp yarn smoothly floats over 3 crisp white weft yarns. Step 2, it ducks cleanly under just 1 white weft yarn. Step 3, this specific, relentless repetition creates denim's signature, iconic diagonal ribbing on the face side. And since those white weft yarns are mostly hiding on the back, you get that highly recognizable white reverse side. It is pure structural mathematics.
Let's shift gears to Phase 3, the chemistry of fading.
This right here is, without a doubt, the single most crucial chemical feat in denim engineering. It's called ring dyeing. During the yarn dyeing process, indigo molecules are intentionally engineered to coat only the exterior surface of the cotton warp yarn. Meaning, if you were to slice that yarn right in half and look at a cross-section, you'd see a pristine, bright white core perfectly untouched by the dye. And that is a stark contrast to typical jeans fabric, where the yarns are saturated 100% all the way through to the core. So let's connect this hard chemistry directly back to you. As you walk, as you sit, as you move through your day, everyday friction causes a progressive chipping away of those outer indigo layers on your denim. And what happens when that outer layer chips off? Boom! It exposes that hidden white core we just talked about. This everyday mechanical abrasion is exactly why your pants develop those awesome high-contrast wear lines. We call them whiskers across the lap and honeycombs behind the knees. Classic jeans fabric, because it's dyed entirely to the core, just fades uniformly. It's never going to give you this personalized, high-contrast map of your life's actual movements.
Time to zoom out. Phase 4, Timeline of Textile Innovation.
We actually started way back in the 17th century when weavers in France accidentally invented a robust warp-faced fabric they called serge denim, which, you guessed it, we later shortened to denim. Fast forward to 1873, and we get the birth of the iconic garment itself when Jacob Davis and Levi Strauss patented copper rivets to reinforce structural workwear. In the 1920s, chemical giants scaled up synthetic indigo, unlocking global mass production. Then, the 1980s completely changed the game with coarse-spun yarns, literally engineering elastane directly into the center of the cotton for the stretch denim revolution. And today, we're using wild green technology like sustainable laser fading and ozone bleaching, which slashes water waste by up to 90%.
Next up, Phase 5, the engineering trade-offs.
Let's open up the official technical spec sheet. Denim is your true heavyweight contender, ranging anywhere from 4.5 up to a massive 15+ ounces per square yard. That gives it insane tensile strength. It uses coarse yarns specifically designed to survive high friction. Jeans fabric, on the other hand, sits firmly in the lightweight category, around 3 to 8 ounces. It uses much finer yarns, and as we've seen, denim delivers that incredible high-contrast ring-dyed fade, whereas jeans fabric is only ever going to give you a uniform color loss over time.
It's a classic game of engineering trade-offs. Jeans fabric has some huge advantages, right? You get enhanced breathability for hot climates, a beautiful fluid drape for flowing garment designs, and a clean, uniform aesthetic that's perfect for a smart casual look. But the cons? They are severe if you're under stress. Jeans fabric has drastically reduced tensile strength, pretty poor structural integrity for holding sharp fashion silhouettes, and absolutely zero personalized fading character. Put simply, it will fail entirely under the high-stress utility conditions where heavy denim absolutely thrives.
And finally, Phase 6, global dominance and applications. Because of these distinct structural properties, the real-world applications are incredibly specialized. Traditional denim's high durability means it totally dominates the 5-pocket pants market, heavy jackets, and industrial overalls. Its extreme versatility is so crazy that it even gets recycled into automotive acoustic soundproofing. True jeans fabric, leaning on its lightweight breathability and drape, finds its perfect home in summer dresses, lightweight chinos, and even the smooth pocket linings hiding inside your heavier jackets.
10 billion plus. That is the jaw-dropping global scale of denim. It is the undisputed king of the global textile market. We are talking about tens of billions of dollars in international trade and literally billions of garments produced every single year. And it's completely democratic, right? It's worn by manual laborers, tech billionaires giving keynote presentations, and high-fashion runway models all at the exact same time. It is a true engineering marvel that has quite literally conquered the planet.
So I'll leave you with this final thought. Take a look at your own wardrobe right now. Based on the hard science, the mechanical geometry of the industrial loom, and the highly specialized chemistry of the dyes we've unpacked today, which side of the material science do you actually wear? Are you wrapping yourself up in heavy, rigid, ring-dyed raw denim, ready to map the physical friction of your daily life? Or do you lean on the fluid drape and uniform comfort of a lightweight, breathable twill? Just remember, the next time you get dressed in the morning, you aren't just putting on clothes. You are wearing centuries of highly optimized engineering. Keep exploring the world around you, and we'll catch you in the next explainer.